Let's have a look at a pipe being used in a real program. This is very similar to the sketch of code I just showed you. So here we begin by creating a pipe. We fork. If we're the child, we connect our standard output to the upstream end of the pipe and we close the downstream end. And then we exec the program ls. If we're the parent, we connect our standard input to the downstream end of the pipe and we close the upstream end, and then we do an exec of sort, passing in the -r option. So what this program is doing is essentially the equivalent of the command line ls piped into sort -r. So let's try running this. And, well, indeed, we see a listing of files sorted in reverse alphabetical order, as we expect. Now, there is a subtlety here. If I just run ls by itself, then we get multi-column output and we get colours. What's happening here is that ls is being super smart. It is checking to see whether its standard output is connected to a terminal. If it is, it does multi-column and colours. If it isn't, then it just gives me a straightforward single column listing, which was what was happening when I ran pipe demo. So here's another program that creates a pipeline. Now this program, pipeshell.c, is easily the longest I've presented in this course, and if you have a Plus subscription to Pluralsight, I recommend you download it and study it in more detail. This is a more ambitious attempt at a shell. This one supports command lines that have options and arguments, and it supports pipelines, or at least single-stage pipelines. So first, here's a function called prompt and parse. Its job is to parse out a command line, placing the individual tokens into an array of strings declared here. And then if it sees a pipe symbol on the command line, it parses the tokens of the downstream commands into a second array declared here. Now, this is one of those pieces of code that you write and then hope that you'll never have to explain to anyone. But from a systems programming point of view, there's nothing going on here. It's pure string handling. So let's scroll down and have a look at the main function. It has a command loop that calls prompt and parse, placing the upstream command's arguments in upstream and the downstream command's arguments in downstream. These are basically two arrays of strings. Now, if there is no downstream command, that is to say, if there's no pipe, we just fork, and we have the child exec the upstream command. Note that here we're using exec vp, so the argument list is supplied as a vector, which you see here, and not as an explicit argument list. But the more interesting case, if we scroll down a little further, is the case where there is a pipeline, so we have to launch both the upstream and the downstream commands. In this case, we fork twice. Once here, and again here. Now, the file descriptor manipulation is what we've seen before. The upstream child connects its standard output to the upstream end of the pipe, and the downstream child connects its standard input to the downstream end of the pipe. So why do we fork twice? Why don't we just fork once and let the child do the upstream bit and leave ourselves as the parent to do the downstream bit? Well, the answer is that as a shell, we need to stay in control. If the parent process does an exec, it loses control. So as a shell, we need to wait for both of our children to finish before looping round to prompt for another command. Notice that the shell is careful to close both ends of the pipe and to wait for both of its children to finish. Now, as a piece of Linux systems programming, this really is at the heart of things. And if I were elected to a position of political power, which is unlikely to be honest, I'd like to introduce a law that every Linux systems programmer should be required to rewrite this program at least once a year to remind themselves of how elegant the whole model is. Well, we have a reasonably capable shell here, so let's take it for a spin. Here's the prompt from prompt and parse. Let's try a simple command. That worked fine. Let's try another one. That worked fine too. Let's try pipeline. And that works as well. What if I try and supply an argument? Let's try a different example. So here we are supplying an argument to the grep command, looking for files that contain tiny in their name. So what doesn't work? Well, lots of things. For example, supposing I attempt a two-stage pipeline. Well, that's a mess. It really doesn't understand what that second pipe symbol is all about. Wildcards don't work either. So there, that ls is complaining that it can't find the file. There's no wildcard expansion going on. Well, okay, we're getting there, but maybe writing a real shell isn't so easy after all.